record one more time. Okay, Waylena, let me introduce you because I just started recording. I can't wait for you to clip that off of there. That's fine. Folks, welcome again to the Starkville Planetarium. This is our Prairie Skies Spotlight Show, which we've been doing to follow our great Kaler Science Lecture Series. It's very much like our other night sky tours, which we do as our seasonal Prairie Skies shows, but we spend a significant amount of time during this show to focus on a subject of interest, either a subject that has been offered by one of the members of our great audience. We've had some where somebody suggested space junk, and that was the subject of our November talk. We also have focused on Mars, and tonight we're focusing on a neat astronomical event that is seen roughly every 20 years, but this one is looking better than any one we've seen in almost 800 years. So that is going to be the conjunction of Jupiter and Saturn, and you're going to see the actual software we normally use in the planetarium being presented by our show producer, Waylena McCully. Waylena, feel free to share your screen and take over the floor. I will sit here and moderate.
All right. Hi, everyone. Now, before I share the screen, I'm going to just take a moment here and I'm going to grab the camera. I want to say how much I do miss everyone, and I miss having everyone here in the planetarium in person. As you can see, I am by myself in here, so it's okay that I'm, not wearing the mask. And I don't know if you can see, but in the middle of the room, you might have to make my screens, my view spotlighted or something. I'm not sure. There we go. Right there. We have, of course, Carl, our star projector, and Carl is still here. Carl does still work. We test him, we check on him, we make sure that he's okay. So I just wanted to let some folks know that because we did get some questions. I got some a few weeks ago about Carl. So I'll go ahead and let him turn his lights off. There we go. Okay, and I'll move the camera back. So normally, what we would see would get projected up onto the planetarium ceiling, all up there. And you can think of it, oh, look at that, I'm all blurry now. That's okay, it'll focus on me again here in a moment. You could think of it as like a giant bowl that's over our heads, and we're projecting imaginary things, a pretend sky up onto that. And that's what I'm going to do is instead of showing that whole ceiling, I'm going to squish it all down into one screen. So now I'm going to go ahead and set up, before I share the screen, I want to make sure that I get an early evening sky turned on. There we go. So now I can share the screen and it will make some sense. There we go. Had to get my share screen button going. There we go. All right. So we've got this rectangular screen with a circle in it, just right there in the middle of it. And that circle matches what would be on the ceiling. And in this circle, I've turned back time to earlier today, so we have the sun right there. Well, of course, it's way past sunset. So I'm going to go ahead and get time moving for us. Have to keep looking over at my controls that are 2 screens away. Seems so far away now. And we'll let it set. And then we start to see the brightest of the stars. Or are they planets? Well, I see some of both, and I'm just going to let it go a little longer. Oh, that's about, that's pretty good right now, pretty close to the time I'm looking for. And if we had the projectors on in the planetarium, we'd be seeing the sky looking pretty incredible. Well, we have found that when we're projecting it through the screen, it does not look, well, all that. So I've come up with a combination of real sky photos and our digital sky. So I'll go ahead and enable that. Oh, much nicer, much nicer. And I set this up as a shortcut for myself earlier, so I wouldn't have to turn all the parts on individually. So this circle matches with our sky, and I'm going to go ahead and put direction letters. Now, if you're using a star map, and I don't happen to have one handy, which is a shame because I know I had one in here last week, the star maps you would use by holding up over your head, and you would match up the letters on the star map with the directions in the real sky. Well, here we've got those directions on the ceiling. Now we want to make it a little easier to see, so I'm going to do something weird. I'm going to stretch it out. So now, oh, look at that, there we go. Had to take a moment for it. I got some weird artifacting on it. So now instead of the circle, we've stretched it out so it's kind of an egg shape. Now, I know that's kind of mind blowing, right? You know what? She just turned the whole sky into an egg shape. That's fine. What I needed it for was stretched out so that we can zoom in a little bit on parts of the horizon. So I'm going to go ahead and zoom us in a little bit like that. So here we are. A little bit earlier this evening, facing south, and we're using a pretend sky setup where we are far away from city lights, so we don't have to worry about that. But here, facing south, and we've got west over on one side, just over here, we've got east over here, and in this view, we have 3 planets that we can see with just our eyes, no telescopes needed. This one way over here, the red one, you know what that one is, right? Which planet is red? Yeah, Mars, the red planet, which in the real sky doesn't look that red. Looks more orange, but yeah, it's still incredibly dazzling to see in the sky. It's still pretty bright, and we still have spacecraft on the way to Mars. So we hope you'll be able to join us for celebration in February as one of those spacecraft lands on Mars, and it's got its own helicopter with it. So yeah, we're really excited about that. But it's these 2 planets over here in the southwest. So I've made a shortcut to go to southwest. These 2 planets are where the action is this month. Oh my goodness. Now, a lot of us have been watching these 2 planets over the summer and into the fall, and now here we are going into the winter. They've been getting closer and closer and closer together every night that I've been able to see them, and it's just been wonderful to watch. In fact, tonight, when I came back here to campus, I parked the car and it was after dark, so I was able to see them, and I stuck my thumb way out, and I could just get my thumb in between those 2 planets. Now, over the next week or so, my thumb will cover those 2 planets. And then as we get closer and closer to the 22nd, they're going to get closer and closer to the point where they might even appear as just one bright thing together in the sky. Now, if you've got really good vision, you're still going to be able to tell them apart, but you're like, wow, those are really close. If I take my glasses off, they're definitely going to look like just one. So if I have my glasses on, then I stand a chance of being able to see them separated. So this is how far apart they are today. And I'm going to zoom in even more. Here we go. That works. And this is, of course, tonight. But now I'm going to step forward in time one night at a time. Okay, so this is what's today's date? The 4th, right? Yes. Okay, so there's tomorrow. There's the next day. The next day. The next day. The next day. Now, here in my view, it looked like Saturn suddenly got less bright. Oh, I gave it away. Oops. Yes, Jupiter is the brighter one, Saturn is the less bright, and we're going to check them out closer up, I promise. I also promise you that Saturn's not going to miraculously become less bright, but what's happening is that each night as we're watching this, the sky in the west, it's going to be a little bit brighter if you're out at the exact same time. And that's because, well, it's getting, we're getting the sunset timing is changing on us. So let's see, this is the sky at, since I went forward in time, let's see, there we go. All right, that was me manually moving our view and making it later so that we won't have as much of the sunset glare. Or I could do, this is something that I learned this from Erik, and I keep forgetting to do it. I should just turn off the atmosphere. I know it solves all of our problems in planetariums. So go ahead and hold your breath. Oh, I'm just kidding. Don't have to hold the breath, but I am going to turn off the atmosphere. So turning that off, and now I won't have that same problem. I don't know why I didn't think of that. It's just not a feature that I'm accustomed to as well. So let me check my date again because I had it here. Ooh, we are up to the 9th. So we're up to next Wednesday. Now notice as we go forward in time, one day at a time, they get closer together, but they also seem to move a little bit together. So that's kind of a neat thing to track as well. So that was the 9th, now the 10th, the 11th, the 12th, the 13th, the 14th. Now the 14th is new moon. And so after that, we're going to find the moon starts to sneak along in here. So we'll see when that happens. So there's the 15th, the 16th. Oh, do you see the moon? Yeah, it might be a little tricky. I could zoom in even more. How about I do that? We'll zoom in even more. Now we're zooming in so much that it's getting a little bit fuzzy because I told you about how this is a combination of the real photo in the background. So yeah, there's going to be a thin crescent moon there on the 16th, just below them as we look at them there in the southwest. But I'm going to zoom out just a little bit more again. Excellent. And so that's the 16th, and so there's the 17th. So the 16th and the 17th, we'll see a crescent moon. On the 16th, it'll be below them, and then on the 17th, it'll be past them. So it'll be a bit above and to the left if you're facing the southwest. But here we go. The 18th, the 19th. At this point, if I don't have my glasses on, they're going to look like they are together. And the 20th, they start to appear very close, and they're even closer on the 21st. The 21st is when they will be at their closest. Now, what's going on here to make this happen? Well, everything moves around the sun. We are on the Earth, we're cruising around the sun, and Jupiter's out there going around the sun, Saturn's out there going around the sun. Now, of course, we know it takes Earth 1 year to go around the sun. That's, well, kind of how we define the year. But Jupiter goes slower around the sun. And Saturn takes even longer. So Jupiter takes about, oh, gosh, of course, I'm on the spot. I'm forgetting my numbers. It takes about 12 years for Jupiter to go all the way around, and it takes Saturn about 30 years to go all the way around. So it does make sense that from our view here on the Earth, we would see them appear to hang out together. We would see Jupiter appear to catch Saturn, and we'd see them hang out together in the sky for a while from our point of view. And so that's just a really neat thing. And most of the time when this happens, though, it's at times when they're so close to the sun's glare that we don't get to see them very well at all, really. And so it's nice that although they're setting shortly after the sun, we are getting to see them. We are getting to see them. So really excited about this because one thing, they're kind of bright. So they look good together. And also, it does happen just after sunset for us to see them. And so I don't have to stay up until the wee hours of the morning to see it because I like to, I like to go to bed when I get tired in the evening. So I'm pretty excited about that. Now I'm going to do something different. I'm going to zoom us out.
And just to repeat, what time do you have this set for right now?
This is set for around 6 o'clock.
Okay.
Around 6 o'clock in the evening. There would be we wouldn't see the stars as dramatically at this time because I turned off the atmosphere and we're looking at an enhanced simulation of the sky. So they'll still stand out pretty well. So if you're watching them over the next couple of weeks, then you'll definitely be able to see what I mean by not seeing, you're not going to see a super dark sky with lots of stars, because even if you are away from the city lights, you still got a lot of glow left over from the sunset at that time. But Jupiter is very bright. Saturn's not as bright, but Jupiter is the second brightest of the planets. Which one's the brightest? I bet you know. Bet you got it. It's Venus. And right now, to see Venus, you got to stay up all night or get up super early and look for it rising ahead of the sun. And I've been up quite a few mornings this week, earlier than sunrise, and I've looked out and up through the trees, out the kitchen window, up through the trees. There it is, super, super bright. And Jupiter's not quite that bright, but it is pretty bright. And so those are the two brightest planets. Saturn is surprisingly bright. I mean, it's still kind of nice. I like Saturn a lot. So this is them on the 21st. Now I'm going to start going back in time one night at a time so I can set it back to our current date. So there goes the moon. Watch me go. Yeah, I went past. I went to yesterday. There we go. Now I'm going to show you this this strange line that we use in planetarium talk. Well, it's not that strange. You might learn about it in astronomy class. It's called the ecliptic, and its official definition is the apparent path of the sun through the sky through the year. I know I sound like I'm singing when I say it. I just get used to saying it so often, but it's kind of neat. So the planets in their orbits around the sun, the orbits kind of line up. They don't line up exactly, but it's pretty neat that they do line up mostly. And so if we look out into space along the path where we find the sun, well, we're also looking out along that same line where we find the planets. So we find the sun, the moon, the planets always on or near that line. And it's marked off in months and days because, well, that's where the sun is. So you see where Jupiter and Saturn are. Well, in January, next month, the sun's going to be in that part of the sky. So it's kind of a neat thing. But you'll notice that Mars is up on that line as well. All right, I'm going to zoom it out because I've got some pictures and things to share, and they're not going to show up very well if I've got it all tilted and if I have the ecliptic still on. How are we doing with questions, Eric? Do we have stuff in the chat, or are you? Oh, you're muted.
I just clicked it to unmute myself, but I already was unmuted. So silly. I had already actually asked that question. There was a question about what time of the evening we were looking at this moment, and how many degrees above the horizon are Jupiter and Saturn on the 16th and 17th. And I typed into the chat that they'd be roughly 10 degrees above the horizon on those dates. They'll be a little bit lower on the 21st at the same time.
Awesome.
Yeah.
Yeah, I can't see the chat right now because of how everything is distributed here. So let's check out a little bit with Saturn and Jupiter. All right, we'll do Jupiter first, because with Saturn I'm going to try something that I haven't tried before, so it might crash the whole system, and if it does that, I want it to be the last thing that we have on our schedule here. So we've got our sky full of stars and the 3 planets, and a little just to orient ourselves. I know we talked about, well, we're going to look over after sunset. The sun sets in the west. There are other ways we can find our directions, and what I think is the most fun is to use the stars in the northern part of the sky to look for the North Star. So I'm going to turn us around to face north. I promise when we're together in the planetarium, I am not going to turn the sky around that quickly. That was 3 seconds to go all the way around. Here in the planetarium, the minimum I would do would be 30, but even that is a little too fast for most of us. So I promise I won't do that. So let's go zoom in a bit. Ah, perfect. So here we have very low. This is just after sunset, very low in the north. We have the Big Dipper, the most famous of the star patterns. And I do think I can do I can do some of the drawings that we would normally do for it here. I have those handy. So yeah, get the Big Dipper there. Fantastic. Fantastic. Now there's something that's kind of neat with the Big Dipper that's sort of related to the whole topic, and I'm going to zoom us in even more for that. And I'm going to manually turn our view. Oh, it's not going to go that way. Okay, so I can't do that by hand. I'd have to use a different control. Yes, I'm going to see. This might disappear from view. Yeah, I'm not going to be able to do that. So I'll have to zoom out a little bit. Well, in the handle of the Big Dipper, there is a star that's, well, if you look carefully at it, it's actually 2 stars. And when you see it in the sky at first glance, okay, yeah, there it is, it's a star. But then you've got good vision. You're like, wait a minute, that's actually 2 there. And it's a famous pair in the sky. The names of the stars are Alcor and Mizar. And some people do use it as a vision test. And in fact, my husband, who I'm going to tease because he's right here on the, he's in the chat right now. He was just earlier saying, do people really not see it that well in the sky? And I was like, yeah, if I don't have my glasses on, I definitely don't see them as 2 stars. So what he was telling me was that, oh boy, and I'm gonna look so I can see him on the screen. We'll see if I get a thumbs up. So on the 21st, actually, you know what? I'm gonna ask you to unmute, Jeff. I'm gonna pull you into this. So on the 21st, how are Saturn and Jupiter going to compare in closeness to the closeness of those 2 stars as seen from here from us?
They're going to be about half the separation of those 2 stars.
So as close together as those 2 stars appear, Jupiter and Saturn are going to appear even closer. Oh yeah, there's no way I'm going to see those separately without my glasses. Thanks, Jeff. I'll mute you again. All right, so that's a neat thing about just something you can do with the Big Dipper in relation to our topic. But back to directions. The Big Dipper is very handy for helping us to find the North Star because we can use the 2 stars, and I have my own drawing here that I can do for it, the same that we would use in the planetarium. The 2 stars at the end of the Dipper's, not the handle, but the other part. Look at that. They drew it just like that. In fact, if you do not, as long as you're not using a touch screen, you can do this. Find the Big Dipper. Don't go to the handle, but go to those other 2 stars. So these two stars. Now draw your line between them, stretch it, beak. That is the North Star. Real name Polaris, which means pole star. And well, if the North Pole, it's always straight overhead. Tippy top middle of the sky, straight overhead, a point that we call the zenith. But from us here where we're at our latitude, no, it's not up that high, but it is always in the same spot. I mean, it appears to move very, very little through the night. It really does very little. So if we find that star, we know we have found the direction north. Because if you do have a good clear horizon, you can see all the way to the ground to find the Big Dipper, you're probably not going to have a giant red letter N sitting there below it. So using the Big Dipper to find the North Star, that works. It works any time of night, any time of year. If you can see the Big Dipper and you're in the northern hemisphere, you can use it to find the North Star. Now, why the northern hemisphere? Because if you're in the southern hemisphere, that North Star is below the horizon. So then, of course, there's the question that people ask, well, is there a South Star? And, well, no South Star. The sky works the same way, though. There's a spot in the sky that appears to not move, that everything seems to go around, that's always in that same spot, but there's no star there, so nothing to use to point to it. Now, the North Star is also known for being the last star in the handle of the Little Dipper. Kind of big, but not as big as the Big Dipper. And those two dippers are parts of the official constellations of the two bears, Ursa Major and Ursa Minor. Now, they don't look like bears. I don't know, weird. I mean, they have these long, fluffy tails. Yeah, real bears don't have tails like that. So there's our directions, and I'm going to zoom us back out.
All right, while you're doing that, I'm going to throw in answers to two questions here.
Sure.
First off, Mark Will says, what is the square footage of the dome screen? I went through the calculations on that. The dome is 50 feet in diameter, correct? Is that roughly the number? Okay.
Yes.
So I went through the formula for pi r squared, and that means that the aluminum that covers the dome is about 3,900 square feet.
Right.
Roughly.
And the actual image space that we would get is a little bit less because back in 2010, we had to add a trough around the edge to put the LED lights. We didn't have a lighting system of that type before. So we've lost a few inches at each horizon. And with the digital sky, we simply compressed it just a slight bit, so we still get our full horizon. It's very slight, but if you're doing calculations and you're getting real precise about it, yeah, we lost a few inches along the cove.
All right, here comes another one. If Saturn and Jupiter will appear that close in the sky, does that mean Saturn will experience an eclipse of the sun in the shadow of Jupiter?
Ooh. Outstanding question. Yeah. So it would not be an eclipse because it's not in line with the sun, but it is in line with the Earth. So it wouldn't be an eclipse, but there's another word that we use for things covering up things in the sky, and that's occultation. Occultation, where it comes from the same word as occlude. So if something covers up something, it's occluding. So my hand is about to occlude the camera. Yeah, nobody needs to see my hand up that close. But yeah, so from Saturn, if you're actually lined up on the other side of Jupiter from us, then it would occult. Jupiter would occult the Earth. Now, I don't think it's actually going to line up that precisely. The interesting question would be, would there be an occultation from any of Saturn's moons? I'm not getting into that. I'll let the
There's
I love
80
to have.
options to choose from.
Yeah,
Totally
yeah. I
understandable.
can already see my husband's face. He's smiling because he's
Yeah.
wondering if he can make that get that calculated out at some point. So
It's
awesome.
really hard to line up things that far apart from each other perfectly.
It is. And that's why it's been such a useful technique for us. We use things covering up more distant things to figure out their distance. And we also used the idea for planets around other stars that are out there, exoplanets. We're able to detect some of them because their brightness changes if one of their planets gets between us and their parent star. These things are so far away. It's just amazing that any of them do line up. So yeah, huge distances and big numbers, and yet works out to being small numbers in our sky when we're measuring how far apart things seem to be. Oh, I love these questions.
Another good question from Kara, and she did put a smiley face on this. I'm just mentioning that. Is the North Star what Santa uses to navigate to everyone's homes?
You know, I have it on good authority that most of the time Santa does use a GPS system.
Oh, wow.
Yes. And, in previous years, we've had our wonderful program, Santa's Secret Star, that tells about what happened when Santa misplaced both his compass and the GPS device. Now, of course, these days it's harder to misplace a GPS device since we've got GPS embedded into our phones, in our cars. I don't think he has one in his sleigh yet. Maybe the elves will get one for him for Christmas. I don't know. You'd have to take that up with them. But Santa does know how to use the North Star now. But yeah, I think he still likes to use the GPS for that.
Plus, he can't use the North Star in the Southern Hemisphere when he's delivering gifts to everybody down there.
Yeah, but I think he delivers to them first. So he usually gets lost when he gets like closer to, usually he gets lost around Detroit and Toledo. I was in Toledo when that was where Santa's Secret Star first came from. I was at the planetarium there. So that's why we always joke about Toledo. All right, well, I'm going to go ahead and set it up for just checking out some stuff with Jupiter. So let me face Jupiter again, and I'll zoom it up. I'm starting to get a little quicker with these controls. Oh, that's nice. That worked out pretty well. I'm saying it worked out pretty well because we don't always have that giant storm facing us. What's the giant storm called? The Great Red Spot. I know we could have come up with a better name for it, but I don't know. I mean, it's kind of reddish orange in color. And honestly, if you're seeing it live through a telescope, you're not seeing this kind of detail when you're seeing it. So you're seeing, stripes, bands of color across it, and the red spot does stand out a little bit more. And honestly, years ago, it stood out even more. It's become less of a less bright red and more of a brownish orange red color over the years, and it's also been getting smaller, at least since the 1990s. And nobody's sure if it's gonna go away completely or if it's going to start getting bigger again. It's kind of neat because it's a storm, but it's been around for hundreds of years at least, because people have only been looking at Jupiter through telescopes for about 400 years. And while there's a little bit of question as to whether they were actually able to see it well enough to be able to tell that it was a separate feature and not just a wider spot on the cloud band that it's associated with there, still, there's been no big change. I mean, there's been no time where people have looked at it through a telescope and not seen it, and then later on seen it. So we have no idea how old it really is, how long it's going to be around. So people who study Jupiter are watching that very carefully. But notice it is not the only storm. There's a lot of smaller ones too. And I love, my favorites lately have been the white ovals. And you can see them sort of to the left in this view. And there's one there, there's one there, there's one there, there's one there. I just love them. They all hang out together. I mean, there's some white ovals in other parts too, but there are just a bunch of them that hang out together. And you even find smaller ones in there. Now I'm going to swap out of this view. And so let me bookmark this view. Clear the old.
Great.
Did we get a question there?
Is there a question in the chat?
Well, I was curious about the person who had just spoken. I think it was Steph over there. If they want to go ahead and ask that question, they're more than welcome to. And
Sure,
we'll
yeah,
to
go
the question
ahead.
in the chat. Go ahead, Steph.
That was an accident.
Oh, that's okay.
Okay, that's all right.
That's all right.
I've got my bookmark set so we can come back to this view if we want, but I'm going to switch it to,
All right.
Erik knows what picture.
Oh, yeah. Well, we do have one other question about
okay,
Jupiter's
yes.
atmosphere, and this is from Mark. Do the bands represent weather patterns in Jupiter's atmosphere? What is the atmosphere made of?
Good question. Yeah, they do have a lot of weather patterns going on there. Now, I don't have a breakdown of the composition of it. I mean, there's obviously a lot of hydrogen, but there's a lot of other elements there to give us those kinds of colors. Something that I find really interesting is that sometimes the weather on Jupiter develops a haze at the top level of one of the bands, and then through telescopes it looks like it kind of fades out and almost disappears for months at a time. So it really is weather. Erik, do you have a breakdown on the composition from the clouds?
So regarding the clouds themselves, that is a number of compounds. Astronomers know that there are actually 3 different chemicals that form those cloud layers, and that's a big reason why we have such a variety of color. The whites you're seeing there are primarily ammonia. And then there are deeper cloud layers made of, yes, water vapor, but that's actually the lowest of the layers, and also ammonium hydrosulfide. Now, those 3 layers themselves won't be enough to explain why we see all these cloud layers, and so there's plenty of other chemicals interacting and absorbing and reflecting sunlight in various ways that are not actually perfectly understood. So it's pretty wild. But yeah, hydrogen and helium are the primary, things you'd breathe in if you were actually in that atmosphere there.
Yeah, I wouldn't try to breathe in Jupiter's atmosphere.
Same.
Of course, the gravity would be so crushing that wouldn't be able to breathe. Oh my goodness. Okay, I'm not even going to think about that. But
Yeah.
let me find.
But the light density, it means you'd have a high-pitched voice like if you breathed in a helium balloon. So that'd be really fun. Yeah.
If I could get any breath, it would be, yeah, the pressure would be just too much for that. All right, I've got this set up. I'm going to switch over to a view of my favorite Jupiter picture. If I can keep from crashing this, I got to zoom it out. That's right. I didn't zoom it out. Maybe I did crash it. I hope not. Oh, I think I may have.
All right, while you're doing
I'm
that,
embarrassed.
it's okay. It's okay. This stuff happens. Mark has a follow-up question about this. He noticed those interesting bands we're seeing on Jupiter and asked if Earth has bands like that too. And then considering how different latitudes have different prevailing winds, like our horse latitudes. And what Mark has really nicely observed is that Earth does have some analogous components to this. Maybe you're familiar with the Coriolis effect, folks. With the Coriolis effect, it's the big reason why our cyclonic storms, our tropical storms, have that rotational pattern to them. And so what's happening is that you've got stuff that moves faster closer to the equator than it does at the latitudes away from the equator. And so when gases move away from the equator, they end up being sped up past all that stuff, and that leads to that appearance of rotation. Jupiter spins a lot faster than Earth does, and it receives a lot more heat from its interior because it's not getting it from a solid surface. So that stuff moves a lot faster. The Coriolis effect is a lot stronger, and that makes really, really tight bands that we can see there. And that prevents a lot of those mixing gases that would make it, I guess, blander in color, you know. Did that give you enough time to set up everything? Hey, there's that.
Oh, yes. Yes. Yeah, I tend to not panic too much when something crashes because I've found a lot of ways to work around the things like that. We've done a few things that to make it work really well through Zoom that it wasn't really meant to do. Sometimes things like that happen with it. But if you have been here before, you might remember this is my favorite Jupiter picture. And this is from the South Polar region. And I love this picture. I have stared at this for hours now. The first thing I want to point out is up at the top of the picture, we've got those white ovals that I was showing. So the red spot's not in this view. And there's some nifty stuff about the cloud tops here. The parts that are dark circles, which I always notice the storms are more circular as we get closer to the poles. But these ones, they're sunken down. So the sunlight is at an angle. It's not hitting them straight on. So that's why they look so dark. And there's one down here, and I don't know if I can zoom in on it. It might distort kind of weird. Okay, that's as far in as I'll go on it. This one here kind of starts to look like a hurricane. And up here, this one looks like a flower. And if I turn my head, this looks like a dragon right here. But it's incredible because the detail from this. Now, this picture is not from Earth. This is from the Juno mission, and incredible images. Please do check out the website for the images on the Juno website because they post all of the images as they come in, and people like you, like me, take the images and process them to get the best details out of the pictures. So citizens are participating in science. This is where folks are, the scientists that study Jupiter are getting ideas of places they want to look at Jupiter more carefully. So yes, we could all take a part in this. It's just such a wonderful thing. Last I heard, we still don't know why it's more bluish at the poles. I've seen some pictures showing some of the northern pole area, and it shows some bluish as well. Still not, they still haven't come up with a decisive answer on that. Let's see, how's the chat doing?
I believe we're caught up.
Okay,
I
good.
did include the link to the Juno images in there, and I had forgotten to include links for the star charts, so oops.
Okay.
But they're there now, so people can go and print off these images that you've produced to show them what's in the sky, to
Oh,
yeah.
I love Jupiter. Jupiter was the first planet that I got to really look at well through a telescope. I had a really dinky toy store telescope when I was little. It really was not, I mean, you couldn't even focus it properly. I could look at Venus to see its phases, but it was not in full focus. It just physically wouldn't, it was poorly built. But when I was at the University of Toledo, my first telescope was their giant 6-inch refractor. I mean, it was huge in length, and all the instrumentation, it was all in brass. Oh, it was great. And Jupiter was the first planet that I got to look at, and the first one that I got to share with people. And I told you Jupiter takes 12 years to go all the way around the sky. Jupiter was in the constellation of Leo. I got to where I could find it in the telescope before the sun set, so we could look at it as soon as the earlier planetarium show was done and everybody came over to the observatory up on top of the next building. And so every 12 years, when Jupiter is again in Leo, I celebrate my Jupiterversary of being in the planetarium field. So it's just a lot of fun, and you can make personal connections with anything in the sky. The important thing is to look and to see things for yourself, and to make those connections. But we need to get a look at Saturn. I know I saved it for last. I did. And let me have us face Saturn. Well, no, that's okay. It's in a good spot. I can zoom it up, because I've set up a magical transporter where we are going to go check it out up close in person. But let's do a little zoom out. See it there in the corner? Yeah. Let's make it bigger. Jupiter's in the way, but that's okay. Yeah, we wouldn't see it that big for real in the sky. That would be kind of fun. It would frighten my cats though. So yeah, I wouldn't want to deal with them. Remy would be just impossible to deal with, I'm sure. But let's go ahead and magically transport ourselves. Oh, I hit a wrong button now. Hopefully it won't destroy everything. I might have to. Yeah, I accidentally hit the evening on sky button. So now I have to wait for it to decide that it could, yeah. I have to wait for it to do that before I can tell it to go back to my Saturn rings close up. I did the same thing that I do when I accidentally mute Erik when we're on Zooms.
Well, I did it to Dr. Hatum Aslan, so.
All right, so what do we notice about our view of Saturn here? I can zoom it out. Looks a little distorted this way, but that's okay. What do we notice? What are those rings? What are those rings made out of? Well, I know when we see Saturn through a telescope, it looks just like the pictures of Saturn, and those rings look like we could run around and around and around on them. Of course, we couldn't do that because they're not solid. They're made of all these pieces of ice and rock and dust, and they all go around together like billions of tiny moons. Of course, they're not all tiny. I mean, most of them are tiny, but some of them are decent size, like boulders. And whenever I'm checking out one of these views of Saturn, now this is what we imagine it would look like if we could be out there checking out the rings for ourselves. I always love to see the shadow of the rings on Saturn. I think that's kind of neat. Now, this is a planetarium, of course, and since this didn't crash the system, I can go ahead and do something really silly, Like, let's see if we can make those ring particles bigger. Okay, that looks like caramel corn. Now I'm really hungry. I'm going to type in their proper size. There we go. Any questions about Saturn or Saturn's rings?
Mark mentioned that they look to him like an asteroid field, and I was going to say that they do remind me of Empire Strikes Back.
Yes. All right. Well, I do hope that everyone here will at least look up once or twice here over the next few weeks to see if you can spot Jupiter and Saturn and see if you can tell that they're getting closer and closer together in the sky. As I said tonight, I saw that I could stick my arm up there and put Jupiter on one side of my thumb and Saturn was on the other. But over the next few nights, it's going to get to where they can just both be covered up when I stick my thumb out at arm's length. So try that, and so see if you can measure the changing, the changing angular distance, as we call it, because it's like angles in a circle. We just look at the whole sky that way, and we can measure how close things appear to each other.
All right, we got 2 questions here. We actually a third one coming up. One from Scott Seekin. Are the images of specific particles actual at some point in history or quote unquote made up?
Excellent question. Oh, my favorite kind, because it gets really nerdy as to the tech stuff here. They are made up, but they are distributed in such a way so that where they have gaps, those gaps are preserved. So they do their best on it, but to my knowledge, I don't think they're really good at mapping individual ring particles. I think they run into a little situation of, okay, well, when is it a giant boulder in the ring, or when do we start calling it a moon? Of course, the moons tend to do things like, I like the ones that are called shepherd moons that help to steer things along, and sometimes you get weird little waves that are noticed in the pattern of the ring material because of how the moons interact. Oh, I wish I had those pictures, Eric. Some of those pictures of the waves in the rings and the spokes. I like the spokes too.
Oh, I've got that. I bring that stuff up all the time. Really, what you're getting at is that the Cassini spacecraft never got that close to individually photograph.
That's what I was asking. Yeah.
So,
okay, fair enough.
So it was all based off of the expected size. You were saying that you have a feature there that shows exactly what the average size would be, and based off of that positioning, that's how they would look at that distance. So there is that. We got a lot of questions coming in now. All right, next one.
Very cool. Thank you.
Yeah, thanks, Scott. Another one from Jeff here. Why do the rings form in that shape as opposed to a chaotic field?
You mean like, why are they just not all scattered? Like,
yeah,
yeah,
that's I think what they're asking.
Yeah.
Gravity
and motion, yes. Gravity and motion, and similar reason that, and Eric, you can correct me if I'm wrong on this, because you certainly spend a lot more time in that realm of physics than I do. Similar to how we've got the planet orbits all in a plane. When you've got these things that are spinning in space and there's gravity, you end up with disks that form from the material that's around them, and stuff just tends to work itself out to be that way. And Eric, where would you go from that to extend on it?
What I would say is that when you've got a certain amount of angular momentum, and people can see my hand, I suppose, even though I have you on spotlight. When you've got that angular momentum there, if something has a little bit of vertical momentum in relation to that, if it keeps plowing through a field of objects,
I spotlighted you.
if it keeps plowing through a field of objects, they're going to slow down, okay? And they're going to lose that vertical momentum over time. And that's why what you see when you've got these planetary systems is that something that starts as a roughly spherical form of gas tends to form a disk, because it will lose that vertical momentum or it will fall right into the center of the star that's forming there. Another one from Psycho Rosenberger here. I see Orion. Can we see Orion as the same shape as what we see from Earth if we're looking at
I'm
Saturn?
so glad someone noticed Orion.
Yep.
It's one of my things whenever I'm watching any kind of movie where, that's set out in space and it's supposed to be some other galaxy or somewhere else. Is like, wait, there's Orion. And we'll back something up to look at to see, yeah, that's Orion. How could it be Orion if it's in another galaxy? Orion would look the same from out at Saturn. The distances that we're talking about aren't that dramatic. In fact, this is in the simulation that we use for our digital system here, and I don't have an artificial, I don't have a photograph behind it. So if we were to keep flying out away from the solar system, then we would start to see the pattern distort as we started to, move away from the area where it looks that way. So yeah, from within the solar system, Orion would pretty much look the same.
It's my favorite part of the demos that we can do in the dome, where we actually leave when we leave and everything, and we see the sky fundamentally changing. It's just fantastic. All right, we got 5 more questions, Elise, here. Steph, what's the best guess on the height of the rings? They look so flat.
Ooh, Erik, you were answering this just in our last Prairie Skies.
Yes, I did say that they're on average usually about the height of, well, the dome that you're under right now, usually about 30 feet. They never get more than 1 mile in thickness. We have some beautiful examples of this, and I'll see if I can find this picture for you all. But when Saturn is on the day of its equinox, where the sun is right over the equator, the shadow of the rings falls onto the planet at its thinnest possible portion, and it's a very extremely thin line, okay? The ring shadows basically disappear, and you can see how truly thin they are. And if I can find that picture quickly enough, I will share it with you all. Oh, I'm so glad I remembered exactly what NASA had called it. Here you go, folks. Follow that link, which is, oof, that's a lot worse of a URL than I was hoping for, but I don't care. That should cover it. It's an amazing photograph that Cassini caught back in 2008 or 9 or so. And the rings will look extremely dark because they're not able to get any sunlight based off of the angle, because the sun's actually perfectly in line with the rings. The only shine you're seeing on the rings is actually coming from reflected sunlight off of Saturn itself. It's Saturn shine that's shining those rings. I love that part. All right.
Saturn shine. I love it.
Okay. From Mark. I believe that both Saturn and Neptune have rings. Do we know whether they're similar in nature and or have the same origin?
Yeah, not just Saturn and Neptune, but Jupiter and Uranus have rings as well. And yeah, similar nature. It's pretty cool. I love that the ones for Uranus, or Uranus is tilted, so it's kind of off of the side there. Saturns are the most obvious from Earth. Anyone with a telescope can see them. Neptunes are more difficult, but they definitely are observed from here on Earth. In fact, one of the ways that they're most easily observed is with that occultation method, where astronomers can watch and notice that stars appear to blink out momentarily as parts of the rings pass between us and those stars. And I always thought that was a really neat way to go about it. So yeah, rings are not all that uncommon in the outer solar system.
Yeah, it's pretty standard for all of those Jovian type planets.
Ooh, I see.
basically.
Yeah, I've got the chat up now, so I can see Pete's
Okay.
question.
Go for
Do
it.
we have, yeah, well, no, I was just going to ask Eric, do we have a email address?
Yeah, I will share Dr. Mitum's email address here with everybody. I saw that Pete had jumped back on, so feel free to correspond with her directly there, Pete, and everybody else can get her email address there too. All right. Hopefully that will help you out.
Such a good talk. Once again, here I was
Yeah.
thinking, oh, I'm going to make all my notes for this one, and then I ended up just getting mesmerized by the previous talk.
Yeah. Yeah, I haven't looked at Jeff's simulation there, but he's offering some other good visualizations for how Jupiter, Earth, the Sun, and Saturn are aligned, or not totally aligned, relative to each other over the course of this month. We'll check that out. Let's see here. Okay, so more comments from Jeff right there. Yeah. I wasn't getting into the main details to respond to Mark's question, but Jeff is saying the same thing there. The reason why Saturn's rings are so spectacular for us is because of them being made out of mostly highly reflective ice. The reason we can't see Jupiter's ring is actually twofold. One is based off of it being mostly dust, but in addition, Jupiter actually doesn't have an axial tilt. That's another big component to it. So even whatever rings it has, they're not going to be able to reflect that much sunlight, because basically on Jupiter every day is the equinox. That's another small issue there. And yeah, being made out of dust, they're not going to reflect as much sunlight, but people can see those rings easily using infrared or using backscattered sunlight if we actually have something behind Jupiter at the moment. So yeah, that's not a guarantee, obviously. So yeah, and dust is the main component for Uranus and Neptune's rings as well. As Waylena was saying, you occult the light from stars in order to see those here from Earth, or you can use infrared again, but they're just not as reflective in any of those cases. Yes, great point there. We didn't really see the rings of Jupiter until Voyager flew past. That was kind of how Neptune's rings got discovered back in '89 as well. Uranus, they found them in advance because there was an actual stellar occultation where Uranus flew in front of a star. Good Lord. I'm gonna share with you folks a cute GIF. And I say GIF. If you folks say GIF, you can say it, but you're wrong. I know I'm giving out fighting words. It's really terrible.
Yeah, that's how I say
I
it.
did it just to be cute. I'm sorry. This one's something I stole off of Wikipedia. Jeff agrees with me. I love it. All right. That GIF from Wikipedia shows you exactly how Uranus's rings were discovered in the late 1970s, a few years before Voyager 2 passed by. It's really neat. It shows a light curve as well, and it shows exactly how it works. It's just really, really fun. So yeah, I've got all sorts of these little slides that I pull up for my lectures in astronomy classes. So, and I'm glad I can share them so quickly with you now. Do you folks have other questions for us? Because I, as you can tell, can ramble about this for roughly 17 hours and people probably want to get going. How do the rings form in the first place? Mark, that's a great question. It kind of goes, I'm sorry, I jumped in. Unless
no, go for it.
It's a lot like how the whole solar system formed in the first place. Okay. Generally, you had this dense, cold cloud of gas and dust, and it got dense enough and it got a little nudge. And I always like to think of it like an avalanche. You had all this mass sitting on top of a mountain, and it's just waiting for something to let that gravity take hold. And it starts to fall, and whoa, okay. Sorry, I got a little bit less coherent there. So everything falls in, all right? But over time, there's going to be some rotation that takes hold in all of that stuff. all right? There will be some angular momentum, and that's what causes it to eventually spin around. And everything then is spinning around in the same direction after a ton of collisions. And by a ton, I'm talking about countless collisions there. And most of that stuff ends up falling in and forming the sun. But some of it is spinning fast enough that it can maintain a stable orbit around the sun and does not fall in. And that stuff coalesces, comes together, and eventually forms planets as well. But in that process of it forming a planet, if you've got something large enough that can be a Jovian type planet like Jupiter, Saturn, Uranus, or Neptune, there might be some stuff that doesn't even fall in on those planets. So you have a little mini nebula, a mini cloud of gas and dust that ends up orbiting around those planets that form. So it's just like a smaller hierarchical scale to those things. I'm sorry, I'm using big words. That ends up forming the moons around those planets. And some of that stuff is too close to the planet, so it can't actually form a moon. So it ends up forming a ring system instead. And that's why those rings are aligned with the equators of those planets. And the moons are actually aligned with those equators too. Waylena was telling you about how Uranus is on its side and everything. Well, all of its moons have that same orbit too. They all have an extreme tilt with their orbits. Yeah. All right, so we both got into the interpretive dance game.
All right, I'm just sharing a last look at Saturn and its rings as we wrap this up. It's just a lovely thing to gaze upon.
Mm-hmm.
And so glad we had so many folks joining us. Thank you all so much. And so let's see, the 18th will be our next regular Prairie Skies. And I'm sure we'll be mentioning Saturn and Jupiter again, since, you know, we'll be getting even closer to that date. And then we'll have more events into the coming year, and we are putting together something special for February 18th, the day that alluded to earlier about the with that Mars mission with the landing, and oh, just very excited about that. And I'm also excited about that because it's about 2:30 in the afternoon our time, so we don't have to try and do anything at 3 in the morning. So it'll be an online event, although, depending on how things are here with students, we might be allowed to have some of the Parkland Science Club students here. But, it'll just depend on how things are out there. But definitely looking forward to celebrating as we lead up to that event. So definitely watch for more from us on that.
Yeah, just stay home for the next 60 days so that we have lower cases. Steph had one follow-up question about what we were talking about with the formation of those moons. You asked, in theory, someday the Earth could have a bonus moon or moons. With that one, when I was talking about all the moons forming around those bigger planets, it's because they got massive enough for it. We see that for planets that are the size of Earth or smaller, they don't have many moons. They were not able to get enough material to draw that stuff in. The gravitational pulls are just so much weaker. Mercury and Venus, which I think we've talked about Venus tonight. Venus has no moons, neither does Mercury. And Mars has two, but they're tiny little objects that were probably actually captured from the asteroid belt. I say probably because we don't know for certain, and there's some confusion about its orbits and whatnot. But yeah, there are lots of captured moons out there, and Mars's two moons are likely two examples of that. As for how Earth got its humongous, amazing, wonderful, love those tides moon, we have a hypothesis. And it's a good hypothesis, but we don't know for certain. It's the joke that I always give in my class is it's like doing forensics on a crime that happened 4 billion years ago. Okay. And forensics are hard enough a half hour ago, right? So, yeah.
All right, well, I think we are good to go. I will, let's see, I'll get the recordings put onto YouTube tomorrow, probably. Erik's usually good about getting them to me pretty quick, so I'll be able to get those onto YouTube, and then we can put on Facebook that they're available.
Oh yeah, our OneDrive holds a goodly amount of data.
Yes.
So, all right. Well, folks, thank you so much for joining us. I'm glad you all enjoyed it. And as always, please feel free to comment to us if you've got requests for seeing something spotlighted for a future show. And we hope you can join us again, because we love just showing things either under the dome, the images we normally show on the dome, or just other simulations that we can offer with other software, okay? So thank you all once again.
Be safe, everyone.